Hi, I'm Lenora Borkhardt. Welcome to the Instructor Resource section of the Science of Disaster course. As you can see, at the time of this course update, we're recording portions of the video during the COVID-19 pandemic.
Hi, I'm Dave Hayden, joining Lenora virtually for this introduction. Lenora and I have been teaching the Science of Disasters course for some time now, and we often do simple experiments for our classes that demonstrate some of the concepts we're discussing. These demonstrations help explain scientific concepts in a simple yet informative way, and also serve to engage the class more fully in fun and interesting manner. So we thought we'd share those with you in the hopes that if you're not already doing so, you may try them with your classes.
The demonstrations included in this resource pack are all homegrown with materials that are available in a grocery or department store and generally for minimal cost. They're listed by subject matter and referenced to the units in which they correspond.
You can do them as part of the unit while instructing, or you can use them as transitions before or after a unit, or when coming back from a break. They only take a couple of minutes and can easily be placed where you feel they are most appropriate.
Dave and I have recorded ourselves performing each demonstration so you can see how each one is done. Our intent was to record them for you as an instructor, but they can also be shown to students if conditions are not conducive to an in-person demonstration because of security restrictions or weather, for example.
We're not professional actors, so use the videos judiciously in class, but they are an alternative to performing the demonstrations with the students when it is not possible to do them live. Some materials, like baking soda, vinegar, and rubbing alcohol, may cause a curious security guard to question you if you carry them into a building, but often we let them know ahead of time what we're bringing and explain why.
It is important to stress to students that each course in the 5-course program is designed to provide a solid basis from which they can build an emergency management career. EL 101 introduces the field of emergency management, describes what we do, and gives them the language to discuss our field. EL 102 provides an introduction to logical, data-based thinking about the hazards we face. This is a nationally scoped class, and while every hazard may not be experienced in every jurisdiction, it's important for an emergency manager to have a basic understanding of all hazards because they may move or may be asked to join a deployment as mutual aid. EL 103 provides the tools to apply the information about the hazards from the EL 102 to assess the risk and to create a plan to address it. EL 146 shows how to create an exercise program to test your plan from the EL 103. EL 105 is about taking that plan and communicating it to the whole community.
So why a Science of Disasters course? As emergency managers, we need to understand not only the hazards that we deal with, but also their causes and ways in which they can be mitigated. Understanding the science of disasters helps to make us and our communities better prepared and more resilient when something does happen.
Understanding what science is and how it works, along with important scientific concepts and principles, form the basis of our programs to address the emergency management mission areas of prevention, protection, mitigation, response, and recovery. Having a basic knowledge of science allows an emergency manager to interact with subject matter experts, convey important warning and preparedness information to the public, and help inform community leaders and officials when critical decisions must be made.
Let's talk about science for a moment. Science is the study of how things work, and it's a body of knowledge developed over time through observation and experimentation. It's a systematic process that seeks understanding, and explanations are accepted as reliable only when they've been subjected to replication and further testing.
Scientific knowledge evolves over time as new knowledge builds on previous ideas. Our understanding is continually being revised and expanded as new information comes to light. This means that our understanding of the universe changes over time with new evidence and will continue to change when new data is discovered.
Science is based on evidence collected by making observations and determining scientific theories and laws to explain those observations. Scientists use theories or models to describe the way our natural physical world works. They use these models or theories to make predictions, test these predictions through experimentation and observation, and use the results to further revise and improve the models. This process is similar to conducting an exercise to test the plan, developing an after-action report on the results, and creating an improvement plan to continually improve.
Science is a collaborative activity, and scientists interact with each other and with the wider world as they try to validate new explanations. Science explanations are inextricably linked to culture, politics, and economics because scientists are part of communities and cultures that view the world in different ways. Emergency management is no different in this regard.
Themes in science and in this course revolve around central concepts like energy, forces, and interactions. All matter is made of elementary particles, interacting through various forces, and with energy in many different forms that transforms everything from molecules to planets. Forces that drive interactions are modeled mathematically and are well understood, and typically tend toward bringing about an equilibrium energy state.
For example, the force of gravity attracts masses and pulls objects toward the ground, reducing their potential energy and thus becoming more stable. Radioactive decay is caused by atomic particles repelling each other and splitting apart, releasing energy and becoming more stable.
The properties of materials derive from the type and arrangement of their particles. Atoms come together to form bonds during chemical reactions, some of which release energy, and in some cases can be explosive. Energy changes during physical and chemical transformations as the bonds between atoms or molecules break or form.
Chemistry is everywhere, and chemical changes are occurring all the time around and within us. The chemical reactions occurring in cells will determine their structure and function. Chemistry also allows us to understand and predict how substances can change under certain conditions, or how they may react to form new substances. Often, these properties can be exploited to cause change at the biological level, or to create energy released in great quantities. These exploitations may be made for good or done with malicious intent, as with terrorism.
There are cycles to everything. Biochemical cycles move the elements essential for life within cells. Weather cycles drive change on Earth and balance and regulate our climate. Geological processes in the form of tectonic, rock, and water cycles constantly reshape the surface of the Earth. The Earth interacts with the sun and moon, resulting in seasonal cycles. These cycles can sometimes be disturbed either naturally or through human activity, where critical thresholds are reached, causing dramatic changes.
Even this course has a cycle. Right now we are in a revision stage, and soon the updated course will be live. Please feel free to reach out to either of us at any time if you have any questions or with suggestions for other demonstrations that you think may be valuable to add to the list. Our contact information is in our instructor biographies included in the resource pack.
We hope you find these resources useful, and we look forward to an opportunity to work with you in the classroom at some point soon.